Pharmacologists have shown that penicillin leaves a person's bloodstream at a rate proportional to the amount present. Let A of t be the amount of penicillin present in the bloodstream at time t after injection. A. Express this statement in a differential equation. The differential equation is the rate, and this rate is proportional to the amount present. The amount present at the moment, it is 8 of t, and this is the rate, so it is dA dt. The rate of change of the amount A is dA dt, and so for part A, the differential equation is dA dt equals Ka, where K is the constant of proportionality. We know that this is a differential equation because it involves the derivative of A and A. Part B. Find the decay constant if 50 mg of penicillin remains in the bloodstream 7 hours after the initial injection of 450 mg. With this differential equation, it is guarantees that we have the solution to this differential equation to be A of t equals the initial amount A0 e to the negative kt, where k is the rate that we need to find. We need to use the negative because this is the decay rate. This is the amount at any time given the initial amount. K is the rate and t is the time. With the given information, we gather that the initial injection of 450 mg means A sub 0 is 450 mg. And so we update this equation and obtain A of t equals 450 e to the negative kt, and with the given information, 50 mg remains after 7 hours. What this means is that if we were to plug in t equals 7 into this equation, k is still unknown, where t is 7. This amount needs to be 50. In this equation, there is only one unknown k. We should be able to find k. To find k, we would divide by both sides of the equation by 450 to get e to the negative 7k equals 1 over 9. And this is an exponential equation, and so we would ln both sides of the equation to get negative 7k down. And so ln of e to the negative 7k equals ln of 1 over 9. Use fraction, don't use decimal number for 1 over 9. Ln of e cancels out, so it gives us negative 7k, or we can move the negative 7k to the front of ln, but ln of e is 1. The right-hand side is still ln of 1 over 9. In the intermediate step, we should leave the answer as ln of 1 over 9 for now. Don't use decimal in the intermediate step. K is ln of 1 over 9 divided by negative 7. And so put this in the calculator. We have k equals 0.314. Rounded to 3 decimal places, or rounded to the number of decimal places that is specified in the problem. This k is the decay constant in the formula, and so we update the equation. The equation is now A of t equals, the initial amount is 450, E is E, negative, k is now 0.314, and t is the variable of the function. This is the the function that gives us the amount of the penicillin at any time t, where t is the number of hours. Part C asks us what time was 200 milligram of the penicillin present. This 200 milligram is the amount at time t. We set it equal to the equation, and this time we will solve for t. We first divide by 450 both sides of the equation to get e to the negative 0.314 t equals 200 over 450, and then we ln both sides of the equation. No need to simplify this because we're going to use the calculator to get the final answer anyway. A good practice, we should simplify this though. ln of e cancelled out, leaving us with negative 0.314 t equals ln of 20 over 45. T is ln of 20 over 45 over negative 0.314. We then input this into a calculator and obtain 2.58. This is the number of hours. It would take 2.5 roughly hours to have 200 milligram of penicillin present or remains if 450 milligram was injected.